Now for this example, we're going to get started with the same familiar structure of basically creating that modeling environment, creating the alternatives to test, and then setting up the basic looping structure using the list map. So steps 1 through 3 actually look pretty familiar. What we're adding in this case is we're adding this new custom node that incorporates all the different custom evaluation nodes that we've created so far. And so we're going to bring in the solar analysis nodes, okay, which will take in the spacing for the analysis points, the weather, and the time study. We're going to bring in the value analysis, which uses sort of a linear interpolation function based on a lowest value, a highest value, and then sets up increments between those values based on the height to height level across the total distance, and then kind of casts some different values based on the height level. And we're also going to take a look at bringing in that directness analysis node, so where we'll use the approach of basically panelizing the U and V panels that we'll use to do the analysis on each of the different walls and kind of point to an object of interest. And we're going to need to set up the inputs for each of those 3 different analyses. So if you have any questions or need a review, go back and look at some of the prior examples so you can see how we set up and created that solar analysis node, the value analysis node, or the directness analysis node. It all starts with this basically understanding those nodes. Now let's go on over to Dynamo for a second and get ourselves started here. I'm going to go back and open the folder. You can kind of find this folder out there on Canvas and the Google Drive. Now as you open it and go looking for the starting point, I'm going to use starting point step 4 as the start for what we're doing. Notice that the folder contains many different custom nodes. Okay, and you're going to need all those custom nodes to go through and build the example. So I just want to show you this to reinforce the point that as you work with your example, it's important that you keep all the custom nodes that you're working with, to make your environment work together in the same folder as your project. Okay, so keep the project, the graph, as well as all the custom nodes together in the same folder. And that way, when you transfer this around and you share it with other people, they'll be able to find everything they need to make the graph work. Okay, so let's go ahead and open up that starting point file. Now at the top of this file, again, this should look fairly familiar. This is this old familiar looping structure that you've seen so many times now. I won't go through and describe that. But what we will point out as we get started is that these are the different inputs that are necessary for the different types of analysis. For the solar analysis node, we needed spacing between the analysis points. We needed the weather, and the weather by location. We needed the sun settings to go through and get a start time and an end time. Okay, and if you need to review that, go back to the solar analysis node example. Actually, let me go ahead and run this just so I can get the initial values and show you what they are. Actually, it's running. I should have. I didn't follow my own advice, which is typically to go through and disconnect the list map so that it wouldn't run all the different cases. Let me do that now. I'll disconnect the list map so we can run these freely without having to worry about doing all the recreating. Okay, so we have a location, which is San Francisco, and that has a weather file. We have the sun settings, which are the springtime solar study. It has a start time and an end time. For the inputs, these you'll adjust based on whatever cost function you're going to use. In the assignment, I give you sort of a cost function to use. And you can think about, this is basically saying the value at the lowest level, like it might be that it costs $500 a square foot to construct at the lowest level, $1,500 at the highest level. There's 750 potential feet and 10 feet for each floor. So that'd be 75 different floors potentially. But again, we'll sort of scale the value between 500 and 1,500 based on what your height is. For the directness analysis, we have a number of panels in the U direction and the V direction. And you can set this, basically, the finer you set this, the more panels are used to do the computation, so it takes a little bit more time. The kind of more coarsely you set this, the lower the number, it kind of uses less panels, so it computes a little bit faster. So as you're getting going, you might start with a smaller number. As you kind of ratchet things up and get closer to the result, you might turn that up a little bit. And then we have the model element itself. Let's go through and just select, that is our object of interest. So that's that statue, the tower, the thing that everyone in your office tower wants to take a look at. Okay, so we've set up the inputs. let's go back and get started down to the next step, which is we're going to create this new custom node to combine the evaluations, calling it, I'm just going to call it combine multiple evaluations. And then we're going to insert these 3 different custom nodes. Actually, there's more than 3 because there's actually 2 for each of the different types of analysis. So I have for each of the different types of analysis for solar, I'm going to select those non-ground surfaces and then run the solar analysis on those surfaces. For the value analysis, I'm going to basically select the mass floors and then estimate the cost by floor level for each of those mass floors. And for directness analysis, I'll panelize the wall surfaces, then compute the directness to each of the objects. So again, go through and if you need to, review the prior examples and you'll sort of see the explanation of how those are created and what the reasoning is behind them. But to integrate them together, here's my new Uber node. What I've done here is just gone through and taken this node, copied its logic, and created this new node by adding the inputs to it. Let me edit this custom node just to have you take a look at it. So you'll see I try to keep these fairly clean so you can organize and see them. Here's the initial logic, the initial looping logic, and the reporting logic. And what I've basically done is to set it up as a series of layers. The solar analysis inputs are right here. The solar analysis code is right here. Notice that since I have it all blocked together in a group, I was able to just kind of copy the entire group, kind of set things up. So basically I was able to copy that group from the prior example just right in here. But what I'm going to do for this one is basically connect the building form, because I want to have the updated building form grab its form, pull out the non-ground surfaces, and then feed them into the solar analysis. That insolation value, the cumulative insolation, I'm feeding into the list create so I can report the values. Similarly, for the value analysis, I have the inputs, I have my nodes that are necessary. I'm going to pull down the building form as an input. I'm going to basically output the mass floor areas. Put a little watch in there just so I can make sure things are working right. Then I'll take those mass floor areas and the values and use that to compute the value. And then I will report that value out as part of the list. Finally, last thing for the evaluation logic, okay, for the directness analysis, we have my directness analysis inputs. I copied and pasted the nodes back in here. So building form, panelize those wall surfaces with a number of U's and V's. Get out a list of surfaces and take those surfaces on the object of interest and compute this directness value. And exporting those or putting them into a list that can then be the output to this node. That's the more proper way to say it. Okay, so we've created our master node. And again, if you need any of the details or want to review how those are created, just go back to the prior examples and we'll explain, it'll, kind of explain in more detail how all those different individual evaluations are created. We're now ready to basically go through and we added those evaluation to the outputs as a list create. We're going to add that new testing node to the testing loop. So we're going to replace the prior node with our new improve node. I'm going to take that combine multiple elevations and tie it into the list map. So it's going to be the list map again, but now bringing all results from our new node in there. Again, we have to choose which of the different results we want. We want just those single parameter values or all the results, because the list map will only return one output. And now it's just basically relinking all of the different values. So parameter name 1, parameter name 2, get all the inputs filled in except for the one that will not be filled in. It'll be filled in by the list map, and that's going to be the combinations to test right there. Okay, let's get the others. We got the weather, the time study, the spacing, value high or value low, value at the high, height at the high, all these things we need to kind of create this cost function, level to level. So those 4 values create the cost function. Then finally, number of U panels and V panels for the panelization for the analysis, and object of interest. Okay, got them all plugged in. That's actually looking pretty good. We are now ready to run. So let's give it a try. Okay, we should watch the tower dance around there a little bit. Now again, there's a lot of different evaluations going on here, so even more than I've stressed it in some of the prior examples, I'm gonna reinforce the notion that as you test this the first couple times, make sure you test it on a very limited number of cases. So, 2 or 3 values of input 1, 2 or 3 values of input 2 at the max. You only want to be testing it on like 4, 6, maybe 9 cases. You don't want to test this on 100 different cases, because if you do, it'll maybe take a long time, especially that solar analysis. Anything that goes off and does kind of an external analysis, okay, and uses a lot of points to do that analysis, could take a long time. So you can figure out whether you're going to get null values back or whether you're going to get some sort of failure along the way just very quickly with a couple different values. If it works, again, only after it works, then go ahead and turn it up and kind of do it for more different cases. So always test with a smaller number of cases just to kind of save yourself some time as you do your debugging. Very good. Okay, so let's come back here and take a look at what the results look like. You can sort of see that for each of the different test cases now, I have the inputs, I have the reported outputs, those are the parameters that got reported, as well as the 3 different kind of computed evaluation values for each of these different cases, kind of all lined up. So it looks like our basic node is working. Okay, now we can think about extending that to more and more test cases, so we can kind of fill out the space a little bit. Okay, as we get started with this whole exercise though, one thing I really want to reinforce and kind of like kind of stress about the overall organization is there's a certain amount of thinking about the mechanics of the nodes and just how to connect the nodes together. But there's also sort of an overall organizing strategy that I've been trying to illustrate through these examples of trying to be very clear about where the inputs are and kind of keep those grouped and isolated. And then as you go working, just kind of grouping different things that may be ultimately considered to be custom nodes together, so it's easy to kind of copy and paste, and to really think about just blocking it together and laying it out in a way that makes it pretty easy to follow later. Because if you think about the total number of nodes that are involved in this entire elevation, it's actually huge. And the only way to kind of like stay on top of it is try and kind of keep on subcompartmentalizing it and limiting the problem at any one area and then kind of building it up slowly. Another point that I hope you're sort of seeing in all this is that, you know, I tend to build things up in small increments at a time. So as opposed to tying, for these purposes, for the examples, I've already built the examples, but behind the scenes as I was building these examples, I really do build them up node at a time and keep on testing things along the way. So it's easy to see where the failure happens. If there is a problem, I can catch it because I need to flatten a list or kind of change the hierarchy of something. If you put all the nodes together into one giant function and then finally just click the run button, the odds of it working are actually pretty slim. So at that point, you have to go back and figure out where the source of the problem is, which is often pretty far upstream. So go ahead and build these, slowly, incrementally. Don't be afraid to disconnect things. If things aren't working, disconnect, see if you can evaluate the nodes that are happening back here before you try reconnecting. That's a really effective debugging strategy, and use a lot of watches to also kind of check on the values. So just some general guidance about how to build something like this, because I know as these nodes all come together, it can get quite complicated. Okay, enough of building that function and kind of computing those. Next up, we're going to look at how we can actually take a look at the values that are returned by that function and try to make some sense out of them in figuring out which tower is the form that we think is best, whatever that might mean.